greetings, and welcome to Thomas's talk about Partclone, a free and open source risk imaging and cloning tool. I'll like a hand of applause, and we can start with Thomas. Thank you.
My name is Thomas Tsai. Welcome to this session. This time I want to share the backup tool, Partclone. And since today covers the second submission and give us the opportunity to share our projects. Partclone is an open source software and mainly used for file system data and storage control. Simply put, we can convert the file system into a single image file, and then we can use to just go to our machine and install and use it. Okay. I am Thomas. I'm from Taiwan. I currently work at SHC. SHC is the National Center for High Performance Computing in Taiwan. And I am also in charge of some HPC cluster, managing HPC cluster and cloud service, and some trust research environment computing in Taiwan. And then we also have some tasks related to open source. We develop and make some projects which is used for HPC machine learning. So we have some projects like VRPO, VIA, and others. Partclone is a free and open source for system clone and restore. And it supports many kind of file system, not just for Linux, but also for macOS, Microsoft, and some VMware, is static. And you can get my source code on the GitHub page. And Korea, this is Korea. Coding feature, and you are a user, you should recommend for this feature. In the beginning, we are focused on VIA and VIA need a file system to back up. And we are from the same Taiwan, HPC, and it's free software. We also have the VIA talk, in this conference. Let's check the schedule. As I mentioned before, we support many different kinds of file systems. Like this, maybe not very well. Okay, we have installation file system and SFS, ZFS, RFS, some almost integrated like the right surface. And we not directly access the file system. I mean, we not just open the file system and read the supervised size something. Normally we follow the streaming tool, like the equal sparks, SMS sparks, other sparks, they kind of streaming tool. They are very good and very easy to use to find some information for Partclone. We still have some different processes like UFS for frequency, VFS for VMware is ESXi, and HFS plus, ABFS, and ABFS is ES, and E for Windows. Because we just always have some nice contributor, nice project for that kind of file system. We just work together, we follow the research, and get the file system information from any kind of tools. We also have some file system not yet support. At that time, we especially if you don't need it or processor. We also have our PD, and we also have an imager and the imaging connection installed from our hardware and the resolution data. We have been work with the players for a time, and they help us, give us a lot of help. In the beginning, we prepared a lot of documents. In the project beginning, we are not really ready. Since the copyright is clear, and we do not have the leverage, change of the orders, and we do not yet support one leverage. But based on what we stated before, we know that kind of business is very important. So we are trying to making them set aside. We schedule sales for churches is very well, and based on this step, we improve that. We have visual data source code, they can compile by themselves. Unfortunately, not every data distribution that they can really support for different file systems is yet. There is the best data distribution. We can get a lot of library support here. And some data distribution is not integrated library or something. So we have several features. We use first of all, this essential file system support. We can just complete essential file system complete. In the beginning, we just directed the drive. It's almost 10 years ago that I reviewed taken the release, data omitted. It's not very popular, so we just take the layout, design it, take the and we have the essential file right now, so we can just take the essential file and we find a tool to compile this file to the page. We just include a style sheet, and then we edit our page file, and we need the SSLD across the feed, and then we can input the essential file and generate the page version. Bitmap that is very good variables that we can easily convert the image into the data file. Not support is not easy because the data is all calculated. And we now know it's important that we the project we will get this support. We can do one support easily. You just need to take the user source code, each output you want to make, and do material support, material support. You just take the data, get this file, and you can generate a PO file, and then see the data on the PO file to different situation. Recently, I just denied the push request from some guys because we use AI configuration to trace the video. But we consider it's really a good idea. We still need some native speaker, native library user to help us to fix everything. So I just dropped the kind of push request. Still, guys, maybe just this is really important. This is in the beginning we test by ourselves. Maybe on that line. This is still easy. So we start trying to write a lot of script for our projects. we have different tests. The first side is optional function test or something like that. File system test. The file system test is quite easy, just create the state machine and we let the virtual machine into time, and then we create a partition, we add a partition, disk and partition, and we format it to the target data, and then we get the checksum from each data, and then we clone and restore to new partition. After that, we check each file from the partition, from the file system, and make sure they are the same file. That is our test. Okay. The base is essentially just like this. The first step is to install. It's a wonderful thing to be able to install with APT because we have taken package right now. And the user just need to APT install by the Partclone. And the second command is for user to clone an extension system. Extension 234 is the same command, same structure. So we can just clone the partition SDA1 to image SDA1 and ESD4, something like that. And after that, someday you want to restore, you can run the same command and you change the option to HR is for restore from the source image to target device. That kind of style, in the beginning, our designs for user, especially legacy user, is very familiar with FSCK or MKFS is similar design. If you want to format, extension 3, you can run MKFS.EST3. If you want to fix extension 4, you run FSCK.EST3. So if you want to clone something, you can clone .est3 or 2 or 3 and NTFS, of course. Okay. Different file systems have different methodology to manage the free space in the file system. So most popular is Bitmap style, like this one. Some advanced file systems like ZFS or Btree, they use different kind of style. Yeah, but here we still use the Bitmap. Like this image, we have 16 block here, and how I know the block is used or not, we just follow the bit record here. So the first two blocks, like block ID 0 and 1, the record is 0, means the block is allocated. And others, like block 2 to block 5, the record is 1, so the block is free. When file system want to find the space to write data, the record is 1 is safe to write data. But for Partclone, we are different. We just find the block record is 0, we back up it. And the free block, we just let it go, ignore it. Yeah. We can dump E2FS. This is a utility from E2FS procs, and you can dump a very detailed information from extension file system, and we can get a lot of information, especially the Bitmap information. It will output the file system structure group by group, so we can get the group 0, group 1, group 3, and in this record we can find the free blocks here. Yeah, so we just check the source code and we get the free block. The free block for Partclone is the block we can jump. We don't need to back up. Yeah. So we start try
trying to trace the source code of dump E2FS. And they have the very important function named in use. And it's reference to other the EST2 test bit to check the bit in the Bitmap and return the block is used or not. So we just base the same idea. The pseudocode is if the in use is used, and then we do backup. And here we not copy the source code from E2FS something. We just link the library because they have the library support, and it's for user space. So if you write a C code or something, you can just link their function directly. You don't need to copy their source code, and this is easier for us to do. Like 10 years ago, maybe extension 3 upgrade to extension 4. At that time, we don't need to do anything. We just continue link to new library, and it worked very well. Library support for Partclone is very important. Maybe not just Partclone, but also for some file system programmer. Yeah. We have some libraries from extension NTFS 3G, VNFS, or Risers. Yeah. But some projects, they provide the library, but it's internal use. So if you compiler, you get the target primary, but the library is internal use, so you cannot get the library for user space to link to work together. And some others do not provide the useful library. They have library, but they cannot provide the Bitmap information or some free space data information. Yeah. So we still need, for that kind of file system, it's not easy to maintain. We really check the source code and get the header file, get the file system structure, everything, and then we merge the code to our project. It's not a good idea and not easy to maintain. Yeah, we know that, but we do not have choice. CI/CD is super popular recent years, and in the beginning, our source code is repository we use GitHub, and yeah, we are still here, and we not yet moved. And we have different workflow for auto test and auto deployment. The first one is for each commit, we will get the latest code and the compiler. And the others for the second one is for Docker image. So if we receive the text commit, and we will generate the container image and auto publish to Docker Hub. And the third one is we will auto run large data I/O test. This page, is like we have many workflow running here. Every push request, the new commit, it will run test automatically. And then we can get the test result. If the test fail, we will receive the notification, and then we back to check the code and fix that. This is the test result. You can see many kind of file system tests here. And this is for Docker image, and we can auto-generate the container image, and we push to Docker Hub right now. In the future, we try to deploy it to different repositories. This is a large data I/O test. Yeah, we need a special machine. Especially, we need some kernel support. So sometimes cloud special VM or the cloud services not work because we have to compile the kernel to support very certain file system. Yeah, like the Riser 4 or something. Yeah. We still test it. we publish the Docker image. In the beginning, I have no idea. I just try it. I have no idea should I do that, but I just give it a try because it's so popular. And some users give me the feedback is good idea because they try. He want to run Partclone, but his Linux is not Debian or Red Hat or something, so it's not easy to get the binary code. So he can just run from the Docker container, just run Docker run, blah, blah, blah. You get the Partclone, and then you can try it. Okay. I have some interesting and advanced usage I want to share here. Here is the command, Partclone command, and I switch to long option here. So if you want to backup extension 4, you just need --clone from the source device and the output to image. You want to backup NTFS partition, file system, the same here. And we can restore, use the same command, you just --restore source image from source image and the target device. And this command, Partclone.restore, is the universal restore tool for Partclone image. So sometimes the user forgot the image is what kind of file system. So we have this one for user. We just give it the Partclone image, and then you can restore to your device. Okay, sometimes some users need to switch the disk, so they want to back up the image. So he can just device to device, partition to partition clone. So user just add the -b from device A1 to device B1. So your file system is copied to the new one easily, just one command. And the pipe is very important feature, especially for Linux user. So we also support pipe for some special case, like this one, we can pipe it, we can clone SDA1 to pipe it to somewhere. I can pipe it to myself to do restore. But you can image. The pipe is very important if you want to archive or you want to compress the image. You can just dump the image to next program. Some users use like the naked NC, so you can pipe to NC and you can transfer the image to other machine, and you run NC from other machine, receive the image, and then you can restore to remote machine. Yeah, we still have many file systems is not yet support. Or some OEM, their hard drive, their partition table is very wide. They keep some data in the out of partition. Anyway, that kind of special problem, we can use Partclone DD to do that. We can run Partclone DD to get the source device and the output to the target device. The results like you run DD directory, but the difference is based on the same UI interface. So for user, maybe they feel familiar with that. Yeah. We provide the imager. Imager also for not yet support file system. We back up the file system we are not support to Partclone image. And you save the Partclone image, so someday you can restore from the universal tool here. Yeah. We have the two interface. The one is terminal TXT terminal interface. The we only have another interface like this one is TUI with anchor sys. So if user try to get the user interface is the only one. We do not yet have GUI. We don't know how to do that. This feature is from contributor, and some contributor, I forgot his name, sorry. And he requested the code for DD rescue. So he has a problem because he has a damaged disk, and he know DD rescue can save his data, but he complained DD rescue spent a lot of time for data, but the data actually the block actually is unused. It's free. So actually, maybe your hard drive, some sector is bad sector, but you can jump. So you don't need to spend time for the bad sector because it's not in use. So we co-work. So he contributed the code, and we have some test. We can use Partclone for that problem. We can generate the domain file. The domain file for DD rescue, like the map, help DD rescue to find the use block and the backup, and do backup by this DD rescue way. So he's very happy because he can save the hard drive, the damaged hard drive, and just the data block, not the trash block. 3 years ago, we started trying to transfer data, block data by BitTorrent protocol. In the beginning, we developed a simulation tool like this one. We generated the image file output to the block file. So you can see each file actually is a block, continuous block. Why we do that? Because we want to transfer the file, the block file to other machine, and they can parallelly work. And the receiver receive block, not save to file, but they write to the disk directory. This is very different. You can image it. We also have the BitTorrent information here. This is the example what we are doing. We work with Cronzilla, Partclone, and the EasyIO. And the EasyIO is, I just mentioned before, he can receive the Partclone data and write to disk directory. So we don't need to the cache storage to save the image and then restore to your disk. We just receive each sector, each block, and write to your disk. Even your disk cannot be mounted, cannot be support anything. You don't care. You just write to your disk based on the Partclone record. Yeah. Okay, we still have some image tool. The first one is dump the metadata only. The second one is to check the image file. Sometimes user complain the image broken, and they have no idea why broken. They maybe transfer the image, and they forgot to have the MD sum checksum or shares checksum. So they got the damaged image, and they restore fail. So we have tool to help user to check the image. Yeah. Some user need some file from the image, but Partclone not support. Yeah, we do not support that kind of things. But third-party project do it, and I test it work very well. Yeah. Partclone NBD is the project they are doing, and we change the format. The old format is deprecated, so it's the second Partclone utility. It's the same thing. They can mount the Partclone image. This is the example. I clone from a file system to the image. And we can run Partclone NBD, which will enable NBD feature in the kernel, module in the kernel, and we run this daemon. And the daemon is running, we can mount the daemon, mount the device, mount the NBD device to MNT, and we get the file from the image. Yeah. That's they are working here. Partclone is not very familiar, but some projects very familiar with the users. Like the Conzilla, many people already know that. It can help user to backup or deploy machines, and it's very easy to use. And Partclone is the default file system cloning tool. And EZL also use Partclone to generate the block file and transfer the block with BitTorrent protocol. And F4G is another project like Conzilla to help user backup and deploy the image, deploy the machines. They also provide the fancy UI. Yeah, that's the features of different projects they are doing. Yeah, Conzilla. Yeah, I know that before, but I never tried it. But I know they are also based on Partclone. Yeah. Yeah, the same. This project also based on Partclone to do file system cloning. Yeah, in the beginning, we not put Partclone and Conzilla together. Our idea is Partclone should be separated, and maybe some other projects or some user can use that directory. That's why I share some other projects use Partclone here. We also have some challenges. Maybe not very clear, but we have some file system layer support. Even Btree we already support, but it's not easy to maintain. We are not good enough because the Btree is cross partition, or we have some limitation here. And the ZFS we still not yet support, because the file system is quite different compared with the traditional file system. And the BMFS we stopped at 3 and 5. We do not yet support newer version because the upstream do not have time to do that. We still need the library support, because we want to help user backup data, but the file system information is not easy to get. So the library, if the upstream they provide the workable and the stable library, that for us is easy to work together. And some users complain they cannot do incremental backup. Yes, we can't. And the user complain the user interface is ugly. Yeah, it's right. Sorry. Okay, this project already run over 10 years, maybe. Yeah, and just want to say thank you for all contributors here, and many thanks for different contributors. If we do not receive their contributor, we cannot make Partclone work like today. This year, I just this year I have APFS. Finally, I have make APFS support. But in the beginning, it's sometimes work, sometimes not, and some use find the problem and send the push request. And I do many tests. It's worked very well. Yeah. So this is the open source themes. We always work together. Yeah. Some file system is very nice developer, but I'm not. So, but they can help me to make the project better. Okay, I am almost done. This is the reference here. Thank you.
Do we have any questions?
Any questions?
It's fine.
I have one question. Nice. Could you start? If the data on the partition that very many of transaction we are trying to clone is likely to change frequently. So how can we ensure consistency during the Partclone process?
Sorry, I don't get. Maybe you can explain more. Sorry.
When the situations are files change frequently, and there is some transaction on the file. So how can you ensure during the cloning process? This is question.
I think I understand.
Oops, careful.
When you clone the thing, the file system must be not mounted. Is that correct?
Yeah.
Long-time user of Partclone and Clonezilla.
Oh, okay. Yeah, expert. Consider expert here. User here. Thank you.
Any other questions?
All right, I think we can give Thomas another round of applause for his great work, and we can end this here. Thank you, Thomas.
Thank you, guys.